Sorry, here at the South Dakota School of Mines and Technology, we're doing, for Thermodynamics II, doing homework 5, which is on activity. Number 5 says, do Krutsky 7.62, which is, the Klein-Black proposed the following model for excess Gibbs free energy. So G is equal to 1 over AX1 plus 1 over BX2, that's all to the minus 1, plus CX1 X2, X1 minus X2 upon D squared. Wow. It says develop the corresponding expressions for natural log gamma 1 and gamma 2. Okay. I need to change that so that it's, I'm only going to have you do I'm only going to have you do natural gamma 1 because this one's already a beast of a problem. Why make it worse? Alright. So, I want natural log gamma 1, which is equal to the partial molar excess Gibbs free energy of component 1, which is equal to dGE dN1 at constant T, P, Nj not equal to 1. Okay. As normal. Now, this is binary. Could I use the binary method? Yeah. Ooh, do I want to? In this case, I'm thinking not, because this thing's even messier than Wilson was. And so I'm thinking I want to use this method because it's just so complicated. There's just too many chain rules and product rules. I mean, it's already going to be fairly complicated, but it's not going to be as bad. Okay. So the first thing I need to do is write down my definition. Then I need to get capital GE, which means is GE times total moles. Okay. And so that's going to equal, so I've got total moles here. Okay. So I've got N total, I've got one, let's write these N total over A N1 plus N total over A B N total, but this is all to the minus 1. Okay. And so now, does that mean I can just get rid of those NTs? I don't know. That seems like some pretty naughty math. So we're gonna leave that be for now. Okay. This one's pretty easy because everything's just there. So N1, N2, N1 minus N2 over N total, quantity squared over N total. Okay. Okay, so yeah, I can bring those down and then I should be okay. Alright. Yeah, I should be fine. Okay, let's figure out this thing first. Okay, so N total, well, 1 over N total is equal to N total times negative 1. Okay. Well, if I do n to the negative 1, I should be able to bring that in. Let's test that out. Let's say I have 2/3 plus 2/4. That's all to the minus 1. And I'm trying to multiply this thing by 2. Will this become 1/3 plus 1/4? Alright, well let's just do that math in my head really quick. Okay, so that is, so 0.5, so common denominator in this case is 12. So I've got 8 plus 6, so I've got 14/12. Is that right? So 8 times 3 is 6, 14/12. Okay, so I have 14/12 times, and that to the inverse, that's 12 over 14 times 2 is going to be 12 over 7. Okay. Re-inverse that, and I should get 7/12. Okay. Well, yeah, so 14 over 12, 12 over 14, because I inversed it, and then multiply it by 2 and I get 12 over 7. I re-inverse it to see what it is if it was still inversed. I'd get 7/12. Is that the same as 1/3 plus 1/4? Is that 7/12? Well, 4 plus, yep, that is. Okay, so that is kosher. Okay, so that's going to make those go away as whole. Okay. Sometimes you just need to do that. Okay. Now I need to take the derivative of this nonsense with respect to component 1. All right. And so let's call this bad boy kappa. Okay. And so so when I'm all said and done, G is equal to kappa to the minus 1 plus Cn1 N2 N1 minus N2 quantity squared all over Nt cubed. Yep, that looks right. Okay. So the partial molar excess Gibbs free energy of component 1 is equal to d kappa dn1 1 all over minus kappa quantity squared. Okay. Plus this thing. Okay. Well, there's a really big product rule. Let's just do them one by one though. Okay. So I've got plus Cn2 N1 minus N2 quantity squared over Nt cubed. Okay. Plus, well, the N2 is constant, so I can move on to the next one. Okay. And so there I have N1 minus N2 quantity squared. The derivative of this is 1 times the derivative of that thing. So I'm going to have Cn1 N2 N1 minus N2 all over Nt cubed. Okay. And then I'm going to have the last one, which is, this thing. So I'm going to have plus Cn1 N2 N1 minus N2 quantity squared times minus 3 all over Nt to the 4th. Yikes. All right. Let's erase some stuff and start cleaning things up. Oh, but I need that but before I do that, let's get that d kappa dn1 going. Okay. So again, kappa was equal to 1 over an1 plus b over 1 over b n2. So d kappa dn1 is equal to, let's see here, that's constant, so minus 1 over an2 a1 squared. Is that correct? Yeah, that looks good. Okay, so RT, natural log, gamma 1 is equal to dkdn1, which is minus 1 over minus kappa squared. Okay, so it's this thing squared. Because that's, so over minus. So I've got really 1 divided by that thing squared, okay, times that thing. So I've got a and 1 squared times, well, this thing, not that thing. 1 over a n1 plus 1 over b n2 quantity squared. Okay, and then I got this thing going on. Alright, well let's get those into x's. We'll figure out the x's on this in a sec. Well actually, okay, there's that piece, that piece, that piece. Let's just start doing the x's. Okay. So I've got RT, natural log of gamma 1 is equal to well, they're both, the n's ones is squared, so I can distribute this n1 into here. Okay, so when I do that, this becomes n1, this becomes n1. Okay, so this is going to equal 1 over a times 1 over a plus x1 over x2b quantity squared. Alright, and then let's see here, we got plus. I do have enough for those all to be x2, so this is cn2 n1, cx2 x1 minus x2 quantity squared plus c x1 x2 x1 minus x2 plus c, minus 3c x1 x2 x1 minus x2 quantity squared. Alright. And this thing ain't gonna clean up much better. It might clean up a little bit, but it's really not gonna clean up a ton. And we can try, but I just don't see it really cleaning up much. We got the time, let's just try to clean it up, but I don't think it's gonna. Okay. Well, everything's to the minus 1, so just let's focus on that. So we got a times 1 over a squared plus 2x1 over x2ab plus x1 squared over x2 squared b squared. Yeah. Okay. And then, so that becomes, let's see here, 1 over a plus 2x1 over x2b plus ax1 squared over x2 squared b squared. Okay. Yeah, not seeing much of a pattern, but hey, let's do a common denominator here to see if things do clean up a little bit. I really doubt it. So we got x2b cubed plus 2x1 x2 squared b squared a plus a squared x1 squared x2b all over a x2 squared b squared. Oh, these are squared. Let's see here. Those are just one of those with a b. And then yeah, this is just a. So this is just a squared x1. Okay. Yeah, still not saying much of a pattern, but hey, that doesn't mean anything. Oh yeah, I kind of see one. Okay. Because on the top I have x1a plus x2b. Yep. Okay, so I have x1a plus x2b all over all over a b squared x2 squared. Okay. So I guess that's how it would simplify, and then of course there would be the inverse of that. And so this becomes a b x2 quantity squared over a x1 plus b x2. So that's as clean as that's going to get. Okay, so that does clean up, which is nice. Okay, let's do this monster. So that has a bunch of x2s in it. They all have x2s and they all have x1 minus x2. So we got cx2, x1 minus x2 times the quantity. X1 minus x2 plus cx plus x1. Yep. Let's see here. Minus 3x1 squared plus 3x1 x2. Oh wait. Oh yeah. Because I pulled that one out, it becomes 3x1 squared, 3x1 x2. Minus. That's also minus and minus, so plus 3x1 x2. Yep. So I pulled that one out. I pulled that one out, so I have x1 times x1 minus x1, okay. Okay. Okay, and then, well, I have a hot mess, if you ask me. So I have 2x1, well, I'm trying to see if I can do something with that 3. Because maybe this is a cubed thing. Because what is it? X1 minus x2 quantity cubed is equal to x1 squared plus 2x1 x2 plus x2 squared times minus 2x2 squared times x1 minus x2, and so that becomes x1 cubed minus 2x1 squared x2 plus x1 x2 squared minus x1 squared x2 plus 2x1 x2 squared minus x2 cubed. There's my 3's. So that one, see, this becomes x1 cubed minus 3x1 squared x2 plus 3x1 x2 squared minus x2 cubed. If I look at that, I've got that guy not close enough. Yeah, shoot, I don't know if I see a pattern. I mean, there might be one. I just don't see it. Yep, those just don't work. Other than if I try to pull things out more. Cx2, x1 minus x2. Let's pull out all the x1s, I guess. So, because they all have x1 except for that thing. Oh, no. Yeah, can't really do that. Well, I can do this. x1, 2, minus 3x1, plus 3x2, plus minus x2. Yeah, that's as clean as it's gonna get, because I just can't see the pattern. So, On this one, if you don't clean it up, I'm not going to take off points. It's just too complicated to not, to clean this thing up. I mean, yes, you could clean up this part, but this one's just too complicated to really clean up nicely.